Welcome back, everybody. Ready for another deep dive. Today, we're taking a look at fractal task management.
Ooh, yeah, this is a good one.
It's a really interesting way to think about tackling big, complex problems.
Right. Using those ideas from fractals.
Exactly. And when I first heard about this, I immediately thought about...
Like ferns?
Yeah, ferns, exactly. Each little frond is basically like a mini version of the whole plant.
It's that self-similarity, right?
Yeah.
And it's super cool how it applies to breaking down tasks.
Okay, so we've got tasks, and we've got this idea of self-similarity from fractals. But what does it actually mean to fractalize a task? How does that work?
So imagine you're building a whole new software platform, right? A massive project.
It's huge.
Instead of trying to tackle that as one giant thing, fractal task management says, let's break it down.
Makes sense.
So you've got layers, you've got the macro level, then the meso level, then the micro level, and each layer is like a mirror image of the bigger picture.
So it's like zooming in on each piece of the puzzle, but they all fit together perfectly.
Exactly. And that's where AI agents come in. They're like the brains of the operation, handling those specific subtasks within each layer.
So it's like a whole team of AI specialists, each one focusing on their own little part of the project.
Yeah. But they're not just working in isolation. They're constantly communicating and adapting, making sure everything fits together.
Right. That makes sense.
Yeah.
But that raises a question for me. These AI agents are working on those individual tasks, but how do they understand the impact on the whole project?
Well, that's where the orchestration part comes in. You have to have AI agent orchestration.
Okay.
It's not just assigning tasks. It's about creating a system where the agents can understand how everything connects. They share progress updates. They can shift priorities based on what's happening. It's like a self-organizing team.
So instead of just focusing on their tiny task, each AI agent has, like, a blueprint of the whole project. That seems incredibly useful, especially when you're dealing with huge amounts of content that are all linked together, semantically.
Yeah.
Like in a metaverse.
Absolutely. The metaverse, the multiverse, whatever you call it, it's deep, right? It's fractal.
Yeah.
That's why this approach works so well. Like, take that skyscraper example.
Oh, yeah, right.
We can break down all those complexities into smaller, manageable pieces, and each piece could be handled by an AI agent, potentially.
Wow. Okay, so this all sounds pretty amazing, but are there any downsides? Any challenges with this whole fractal task management thing?
Well, yeah, like anything, there are some things to watch out for. Over-optimization is one. If you focus too much on simplifying and breaking things down, you might miss those nuances.
Oh, right. You don't want to lose that human touch completely.
Exactly. You need that balance. And then there's the accountability question. As AI agents are doing more, we have to be really clear about roles and responsibilities.
And making sure we can understand those decisions they're making, too.
Transparency is key.
For sure. Okay, now, what about data privacy? I mean, if information's moving across all these different layers, how do we make sure sensitive stuff is protected?
Yeah, that's huge. You have to have really strong security measures in place at every level of that fractal structure.
So no weak links.
Right. No weak links. Okay, so we've talked about the big picture, but let's get into the nitty-gritty. What are the core components that make this whole thing tick?
Yeah, break it down for us.
So you've got three main things: task decomposition, AI agent orchestration, and workflow design.
All right, let's take them one by one. Task decomposition, what's that all about?
Basically, that's where you're breaking that big problem down into all those smaller subtasks, using that fractal structure as your guide.
Got it. So that's step one. Then we've got AI agent orchestration, which we've touched on a bit already.
Yeah, that's about managing all those AI agents working on those subtasks, making sure they're working together smoothly.
And finally, workflow design.
Workflow design is all about how you organize those subtasks and how the results from each one feed into the next stages of the project, like an assembly line, but way more complex.
So task decomposition breaks it down. Agent orchestration manages the AI team, and workflow design makes sure everything flows.
Exactly.
Okay, this is all starting to click. But where is this actually being used? Give us some real-world examples.
So one cool example is in software development. Agile methodologies already break projects down into smaller sprints.
Right.
Fractal task management takes that even further. Using AI to manage those sprints, you can have AI agents writing code, testing for bugs, even suggesting improvements.
So like an army of super efficient programmers working 247. What else? What other applications are we seeing?
Research and development is another area where this is taking off. Imagine using it to structure those complex scientific experiments.
Oh, wow.
The AI can manage different stages of the experiment, analyze data, even help researchers draw conclusions faster. It could lead to some amazing breakthroughs.
So medicine, material science, things like that.
Exactly.
It seems like the possibilities are endless. Is there anything where this approach just wouldn't work?
That's a good question. I mean, it's broadly applicable, but there are definitely situations where a purely fractal approach might not be the best fit.
Okay.
For example, if you've got a task that really needs that human creativity or intuition.
Right, and so this just can't be automated.
Yeah. And projects that are constantly changing, where the requirements are shifting all the time, might need a more flexible approach.
So even though fractal task management is powerful, you've got to choose the right tool for the job.
Absolutely. It's finding that balance, between structure and flexibility and using the best of human and artificial intelligence.
This has been a really great overview. We've covered the basics, how it works, some real-world applications. But before we wrap up this part, I want to dig a little deeper into something we touched on earlier. This whole idea of managing content in these constantly evolving digital worlds, like the metaverse.
Oh, yeah, good point. We've talked about how the fractal nature of information is a good fit, but there are some unique challenges when you're dealing with these massive amounts of data, all interconnected and constantly changing.
Yeah. Let's explore that further.
Yeah, so picking up where we left off, one of the biggest things is scale.
Right.
We're talking about potentially billions of pieces of data, all connected, constantly changing. It's mind-boggling.
Traditional systems just weren't built for that.
Nope. But fractal task management, it can handle it because it breaks everything down
Into those smaller units.
Exactly. So each piece of content, like a 3D object, code, a user interaction, it becomes its own task.
Okay.
And it can be managed independently, but the system makes sure it all works together like a well-oiled machine.
So it's like, I don't know, a giant library.
Oh, I like that.
Where every book, every chapter, even every paragraph can be managed separately.
Yeah.
But it all still makes sense as a whole.
Perfect analogy. And that's crucial because things are constantly changing in these environments. Content's being created, updated, deleted. The system has to be able to keep up.
It's got to be flexible. That makes sense.
You're right.
But what about version control? Keeping track of all those changes over time. How does fractal task management handle that?
That's where that hierarchical modularity comes in. Remember we talked about the different levels.
Macro, meso, micro.
Right. So each layer can actually represent a different version.
Oh, interesting.
So you might have the macro level, that's the overall structure, then the meso level, that's like a specific area, and the micro level, that's those individual objects within that area.
Okay.
And as things get updated, the system can create new branches, new layers to track those changes.
That's really clever. It seems like that'd be perfect for those collaborative design projects.
Yeah.
Where multiple people are working on the same stuff at the same time.
Yeah, absolutely. And it also helps with reusing content. So you've got a 3D model of a tree, and it's used all over the place. With fractal task management, you only have to update it once. No more going through and changing every single tree manually.
That would save so much time.
Huge time saver. But there are some challenges, of course. Like, you need to make sure those AI agents are talking to each other.
Oh, yeah, good point. If they're all working separately.
They've got to be able to share information, resolve conflicts, stuff like that.
So how do you make sure they're actually working together, not just doing their own thing?
Well, that goes back to that AI agent orchestration we were talking about.
Right.
We need those algorithms, those protocols that allow them to communicate, to understand each other's goals, work as a team, basically.
So it's not just about giving each agent a task. It's about making sure they can function as a unit.
Exactly. And as these environments get more complex, that orchestration is going to be even more important.
For sure. And, another thing that comes to mind is data privacy.
Oh, yeah, that's huge.
With all this information floating around.
It's got to be built into the system from the ground up. Security at every level.
Encryption, access control, all that.
Yep. And it's not just about protecting the data, it's about being transparent with users.
Right. Letting them know how their data is being used, giving them control.
Exactly. That's how you build trust.
Absolutely. Okay, so we've talked about the good stuff, the challenges. Any other potential downsides we should be aware of?
I think one thing to be careful of is becoming too reliant on automation.
Oh, interesting. Letting the machines take over completely.
We don't want that. Humans still need to be in the loop, especially for those big decisions.
So it's about finding that balance again.
Exactly. Automation can be great, but it's a tool. It's not a replacement for human judgment.
Right. And then there's the whole issue of bias.
Ugh, yeah, that's a big one.
If those AI agents are trained on biased data, or if the algorithms themselves are biased,
It can lead to some really unfair outcomes.
that's a problem.
It is. But researchers are working on it, trying to find ways to identify and mitigate that bias.
It's something we definitely need to keep an eye on.
Absolutely. It's clear that there are some incredible opportunities here, but also some risks. We need to be aware of both as we move forward.
Enthusiasm and caution.
I like that.
Okay, so before we move on to the future of all this, let's recap what we've covered so far. We started with the basics, breaking down those complex problems.
Right.
Then we talked about those three key components: task decomposition, AI agent orchestration, and workflow design. And we look at some real-world examples.
Software development, research, all kinds of things.
Yeah, and then we shifted gears to those unique challenges of using this in these dynamic digital environments, like the metaverse.
Scalability, flexibility, version control, data privacy, all that good stuff.
We also talked about the need for those AI agents to communicate effectively.
And the potential risks of over-reliance on automation and bias.
A lot to think about.
Definitely.
Okay, so before we jump into the future, I want to circle back to something you mentioned earlier. This whole idea of semantically mapping content to these digital spaces.
Oh, yeah, that's important.
Can you unpack that a little bit? What does it actually mean? And why is it so important?
Yeah, so semantic mapping, it's all about adding that extra layer of meaning, giving those digital environments more context.
Okay.
It's not just about having a bunch of objects, it's about understanding what they represent, how they relate to each other.
So it's like instead of just having a virtual tree, you'd know what kind of tree it is.
Exactly. What its properties are, its history, you can create much richer experiences that way.
I see. So it's about going beyond the visuals.
Yeah, you're embedding knowledge into the environment itself.
Okay, so how would that actually work? Give me an example.
Sure, imagine a virtual museum.
Okay.
Every artifact is tagged with information, its history, its cultural significance.
So you could learn about it just by interacting with it.
Exactly. You could explore at your own pace, dive deeper into the stuff you're interested in. There could even be virtual curators, to answer questions.
Wow, that's way more engaging than just reading a textbook.
Right. And this could be applied to so many things. Virtual cities, for example.
Right.
Every building, every street tagged with data. For urban planning, disaster preparedness.
Or even just helping people get around.
Exactly.
That's like bridging that gap between the physical and digital.
Yeah, and as AI gets better, we'll see even more amazing applications.
That's a perfect segue to my next question. The future of fractal task management. What are you most excited about?
Well, one thing that really blows my mind is the potential for integrating this with other technologies.
Like what?
Quantum computing, blockchain. I mean, quantum computing could help us solve those really tough optimization problems.
Oh, wow.
And blockchain could provide that secure platform for tracking tasks and resources.
So we're talking about some next level stuff here.
Oh, yeah. And then there's the advancements in AI itself, natural language processing, computer vision, all that.
Right.
We'll be able to create even smarter AI agents. They'll be able to handle more complex tasks, adapt to new situations.
So they're not just following instructions, they're actually learning and problem solving.
Exactly. And even collaborating with humans on a whole new level.
That raises some interesting ethical questions, though.
It does. But I think if we're careful, if we prioritize human values, we can use these technologies for good, to solve real-world problems.
Make the world a better place.
Exactly.
Well, this has been an incredible deep dive. We've covered so much ground.
Yeah, it's been a great conversation.
From the basics of fractal task management to the mind-blowing possibilities of the future.
I hope our listeners are feeling inspired.
To learn more and maybe even apply some of these ideas in their own work.
Absolutely. Keep exploring, keep asking questions.
And until next time, keep diving deep.